Chem Mastery, your study buddies.
Hello everyone, welcome back. We are Chem Mastery. Today we will discuss about chapter 6. In this chapter, we will learn regarding acids, bases and salts. Here is the overview of this chapter. We will learn about acid and base and then proceed to the salt, and then we have some tutorials, and then we have a bit of quiz. For students who got the highest mark will be rewarded handsomely, so don't forget to try and claim your prize. Let's start our discussion. Today we are going to learn about acid and base. Acid and base, we learn the definition, the preparation of standard solutions, the usage of acid and base in daily life, the pH value, the strength of acid and base, the neutralization, the role of water to show acidity and basicity, also the chemical properties. Here we are going to look at the acid first. Okay, for acid, when acid is dissolved in water, the hydrogen atoms in acid molecules are released in the form of hydrogen ions. That is the properties of the acids, and that is why it is defined as a chemical substance containing hydrogen ions in a aqueous solution. We will look at the example of based on the definition later. We look at the basicity of the acid first. Basicity of the acid. What does it mean by the basicity of the acids? It means that the number of hydrogen ions that can be produced by an acid molecules that ionize in water. For basicity of acid, we have monoprotic, diprotic, and triprotic. For monoprotic, it means that acid that can produce only one hydrogen ion from each molecule. For example, hydrochloric acid. You can see it has only one hydrogen ion. And then as for diprotic, based on the word itself is saying di, so it means two. It means that acid that produce two hydrogen ions from each acid molecule. For example, sulfuric acid, we can see the chemical formula is H2SO4, and then the hydrogen has two hydrogen. It means it has two hydrogen ions. And for triprotic, it means the acid that produces three hydrogen ions. You can see this at the phosphoric acid. It has three hydrogen ions. Let's move on. Here we are going to look at the example. The example given here is hydrochloric acid. See, we see that it has hydrogen ion and a chlorine ion. But what happened when it dissolves in water? When it dissolves in water, it will ionize and give hydrogen ion and chlorine ion. This is what that proves the definition. Here we are going to look at the bases. What is bases? Bases are the chemical substance that reacts with acid to produce salt and water. And then we see base has an alkaline. And what is alkaline? What the difference between base and alkaline? Alkaline means it is a base that dissolves in water to produce hydroxide ion. If the base does not dissolve in water, it is called base. But if the base dissolves in water, it's called alkaline. And here we have the example, which is metal oxide and metal hydroxide also is one of the base. This is because when this metal oxide and metal hydroxide react with acid, it will produce salt and water. It is called base because back to the definition of base, it is a chemical substance. When react with acid, it produces salt and water. This is why metal oxide and metal hydroxide also called base, because when it reacts with acid, it gives salt and water. Here are the example of base. We can see zinc hydroxide. It reacts with hydrochloric acid, and with the base and acid react together, it will give salt, which is zinc chloride, and water. So today we are going to look at the usage of acids in daily life. It has a lot of usage, which is it may a chemical substance, but for example, sulfuric acid used in detergent and paint, and also for ethanoic acid used in vinegar and also glue, and for carbonic acid, which is we use it in drink, a carbonate drink. Look at the usage of base in daily life. We have, for example, magnesium hydroxide. We can find it in the toothpaste, in antacids for gastric, and then we can look at the sodium hydroxide. We see the soap and bleach. Here are calcium hydroxide. So there is a lot of usage of acid and base in daily life. It's the matter is whether we know and we're concerned about it. So here we are going to look at the role of water to show acidity. We can see with the presence of water what happened, and without the presence of water what will happen to the chemical. So we look at the presence of water first. When it has presence of water, it will be important for information of hydrogen ion. And then with water, the acidity can show its presence. And we know with the presence of water, when acidity can show its presence, and it shows the properties of the acid, which is properties of the acid, it has pH lower than 7, and litmus paper change from blue to red color. And then when acid shows its acidity, it reacts with metal, base or alkaline, and carbonate. And also it can conduct with electricity due to free movement of ion. So that is why when water when acidity is shown in the presence of hydrogen ion. So next, let's us look at the without water. What happens when there is no presence of hydrogen ion? So the acid molecule remain unchanged, and when no presence of hydrogen ion, the pH stay at 7, which is neutral. And then there is no change of color litmus paper because the pH is neutral. And then when neutral, there is no reaction with metal or alkaline or carbonate, and it do not conduct with the electricity. So we are going to look at the role of water to show basicity. What happens when base is dissolved in water? It is important to formation of hydroxide ion. And then when dissolved in water, the basicity shown as the presence of hydroxide ion, which is can be looked at the pH. When the pH is greater than 7, and the litmus paper changes from red to blue, and then the base can react with acid and ammonium salt, and it can conduct electricity due to free movement of ions. And what happens when base does not dissolve in water? Of course, there is no presence of hydroxide ion. And what happens when there is no presence of hydroxide ion? The pH will stay the same, 7, which is neutral, and then there is no changes of color of litmus paper, and when there is neutral, there is no reaction with acid and ammonia salt, and it cannot conduct the electricity. So here we are going to look at the pH value. So what is pH value? It is a measurement of acidity and alkalinity based on a scale from 0 to 14. Here we can look at the scale, the pH scale, which is 0 to 14. If the compound is at 7, it is a neutral compound, and if the compound is less than 7, it is an acidic compound, and if the compound is more than 7, it is an alkaline compound. Here we can look, the more acidity of the solution, the higher the concentration of hydrogen ion and the lower value of pH. For example, for pH 1 and pH 6, pH 1 is more acidic compared to pH 6. This is because pH 1 has higher concentration of hydrogen ion. And let's look at the alkaline. The more alkaline the solution, the higher concentration of hydroxide ion and the higher value of pH. For example, we have a substance with pH 10 and pH 14. It is mean pH 14 is more alkaline compared to pH 10 because it has higher concentration of hydroxide ion. But be careful, for a compound that has lower pH for acidic, it is a very dangerous compound, and for an alkaline that have very high value of pH is very dangerous alkaline. So we are going to look at the formula for finding the pH and pOH value. For determination of pH value of an acid, we can use this equation, which is pH equals to negative log concentration of hydrogen ion. Make sure the unit is in milligram in per liter. And also for determination of pOH value of an alkali, can use this equation, pOH equals to negative log concentration of hydroxide ion. Also the unit in milligram per liter. And for pH with pOH adding together, the value will be 14. If the question does not have concentration, either hydrogen ion or hydroxide ion, we can use this formula to find pH or pOH. For example, if the question wants to find pH, we can use 14 minus pOH. And if we want to find the pOH value, we can use 14 minus with pH. So we are going to look at the question. The question is, pepsin, a digestive enzyme in our stomach, has a pH of 1.5 and find the concentration of hydroxide ion in the stomach. We know the pH is 1.5 and we need to find the concentration of hydroxide ion. So based on the formula pH plus pOH equals to 14, we can find the pOH by subtract 14 with pH and substituting the value of pH, we get the answer of pOH, which is 12.5. And to find the concentration of OH, we can use this formula, which is pOH equals to negative log concentration of OH. And by substituting the value of pOH, which is 12.5, and we interlock the value, we get the concentration of OH is 3.16 to the power of negative 13 molar. To the next slide, we are going to look at the strength of an acid. We have strong acid and also weak acid. For strong acid, it is completely dissociated in water and it causes the high concentration of hydrogen ion. For example, we have hydrochloric acid, nitric acid, and also sulfuric acid. And for weak acid, it is partially dissociated in water and it causes low concentration of hydrogen ion. For example, ethanoic acid and also phosphoric acid. We are going to look at the strength of bases. We have strong bases and also weak bases. For strong bases, it is completely dissociated in water and it causes a high concentration of hydroxide ion, which is the example is sodium hydroxide, potassium hydroxide and also lithium hydroxide. And for weak base, it is partially dissociated in water and it causes a low concentration of hydroxide ion. For example, we have ammonia and also ammonium hydroxide. Next, we are going to look at the chemical properties of an acid. It has three properties. Number one, what happens when acid reacts with reactant metal? Second, what happens when acid reacts with carbonate? And third, what happens when acid reacts with an alkali? This process is actually a neutralization, which when acid reacts with alkali, it will give salt and water. So we are going to look at what happens when acid and reactive metal react together, and also when acid and carbonate react together. So here we are going to look at the chemical properties of an acid, which when acid and reactive metal react together, it will form salt and also hydrogen gas. So here is a bit of video of how the procedure happened. So this is a sulfuric acid being poured in the test tube. Then it will be react with reactive metal, which is in this experiment, magnesium is being used. But we also can use lithium or potassium, depending on the reactivity. And when the magnesium is into the acid, you can see the bubbles here and the gas released. This gas is actually a hydrogen gas. Okay, so we can move on to the next properties. So here we are going to look at the how acid and carbonate react together, which is it will form salt and also water and also carbon dioxide. You can see when this acid also react with carbonate, it will form a carbon dioxide gas, and this bubble means there is a carbon dioxide being released. And if you want to identify the carbon dioxide, we can use the lime water test. If the lime water turns cloudy, it means there is a carbon dioxide gas. So let us move on to the next slide. Same for the acid, base also has its own chemical properties, which is first, what happens when alkali and acid react together. This reaction is what we call neutralization. When alkali and acid react together, it will give salt and water. For example, when sulfuric acid reacts with potassium hydroxide, it will give potassium sulfate and water. And for the second properties, what happens when alkali react with ammonium salt? It will give salt, water and also ammonia gas. Here we can look when ammonium chloride react with sodium hydroxide, it will give sodium chloride, water and also ammonia gas. Okay, for the last properties, what happens when alkali react with metal ion? In this example, we can look when sodium hydroxide and alkali react with metal ion in magnesium, it will give magnesium hydroxide, which is a insoluble metal hydroxide. Magnesium hydroxide here is a white precipitate and thus not soluble in water. Next, we are going to look at the concentration of aqueous solution. So what does it mean by the concentration of aqueous solution? It is a measurement that shows that the quantity of solute dissolved in a unit of volume of solution, usually in 1 decimeter cubic solution. So if you want to calculate the mass of solute found in 1 decimeter cubic solution, we can use the formula. It's a concentration equals to mass of solute in gram divided with volume of solution in decimeter cubic. This formula, the unit will be gram decimeter per cubic. But if you want to calculate the number of moles of solute found in 1 decimeter cubic solution, also known as the molarity, the calculation can be done by when the number of moles of solute divided with the volume of solution in decimeter cubic. So we get the molarity with the unit mole decimeter per cubic. If we have the question and the question wants to us calculate from the concentration to the molarity, we can use this, which is concentration divided by the molar mass, we can get the molarity. And for molarity, we multiple with the molar mass, we can get the concentration. So this is a formula that you can use to calculate the concentration or the molarity of the aqueous solution. Here we are going to look at a question for you to enhance the understanding. So the question is, determine the molarity of 0.44 mole of cobalt chloride in 0.654 liter of solution. So first of all, we have the number of mole of the solute, which is 0.44 mole, and then we know the volume of solution is 0.654 liter. So remember, this liter, 1 liter equals to 1 decimeter cubic. So 0.654 liter equals to 0.654 decimeter cubic. Let's continue. So what is the molarity? So we need to find the molarity in mole decimeter per cubic. Based on the formula, molarity is the number of moles of solute divided with the volume of solution. So we can just simply put, because we already know the volume of solution based on this conversion. So the number of mole is given 0.44 mole divided with 0.654 decimeter per cubic. So we get the answer for molarity is 0.679 mole decimeter per cubic. So this is the way how to do this question. So move on to the next slide. We are going to look at the relationship between number of moles with molarity and volume of solution. If the value of molarity and the value of solution are known, so we can calculate to obtain the value of the number of mole. So from the formula of molarity, we know that molarity equals the number of mole divided with volume of solution. So if we convert this in a symbol, so we get molarity equals to N over V. So if you want to calculate the number of moles, we have N equals to M multiplied with V. This volume is in decimeter cubic or in liter, and in this the volume is in centimeter cubic or liter. So if the volume is in centimeter cubic or milliliter, it needs to be divided by 1000. So here we are going to look at the question. So the question is, calculate the mass of the hydrochloric acid in 300 centimeter cubic solution of a 2 mole decimeter per cubic hydrochloric acid, and the molar mass is given. So what we are going to do is, we know the volume of solution is 300 centimeter cubic and the molarity is 2, and then what is the mass? To calculate this, we can use the formula mv over 1000. We can substitute, this molar is 2 and the volume is 300, and then we get the mole is 0.6. And then to find the mass, we need to times the mole with the molar mass. And how to get the molar mass? The molar mass of hydrochloric acid is by adding hydrogen and chloride, which is hydrogen is 1 and chloride is 35.5 gram per mole, and then we get the molar mass at 36.5 gram per mole. So the answer is the mass of hydrochloric acid is 21.9 gram. So here we are going to look at how to prepare the standard solution. Standard solution is a solution in which its concentration is known, so it can be prepared by weighing method. So this is a experiment. We can weigh the sodium hydroxide, and then we dissolve the sodium hydroxide in distilled water. Make sure it is dissolved completely, there is no residue, and then carefully transfer the solution into a volumetric flask and add distilled water until it reaches the calibration mark. This is how we put the distilled water until calibration mark. Make sure our eyes are perpendicular with the gradation mark, and then this is the meniscus. Here we are going to look at the dilution method, which is a process of adding H2O to the concentrated of standard solution to get more diluted solution. So we can see there are two formulas here, M1 V1 over 1000, also M2 V2 over 1000, or M1 V1 equals to M2 V2. So M1 is the molarity of aqueous solution for initial dilution, and V1 is the volume of aqueous solution in initial dilution. M2 is the molarity of aqueous solution for the final dilution, and V2 is the volume of aqueous solution for the final dilution. Here, the formula is used, the volume is in centimeter cubic, that is why it is being divided by 1000. And this one, the volume is liter, so there is no need for divide with the 1000. Next, we are going to look at the question. So the question is, calculate the volume need to prepare 5 decimeter cubic of 2 mole decimeter per cubic nitric acid from 18 mole decimeter per cubic of nitric acid. So we have molarity before dilution, which is 18, and then volume before dilution, unknown, and the molarity after dilution is 2, and volume after dilution is 5. So we can use the formula M1 V1 equals to M2 V2. The reason we don't use M1 V1 over 1000 equals to M2 V2 over 1000, this is because in this question it is given the volume is decimeter cubic. So decimeter cubic is equal to liter, so we can use this equation. So proceed to the calculation. We can just substitute the value. So we can get the volume before dilution is 0.556 decimeter cubic. We are going to look at how the dilution method works. So there is a pipette. 25 milliliter of sulfuric acid is being transferred to the volumetric flask, and then it's being mixed with a little bit of distilled water, and then we fill the volumetric flask with distilled water until the calibration mark. We are going to look at neutralization. What is actually the neutralization? Neutralization is actually when a reaction of acid and alkali together, it will form salt and water. For example, this equation, we can see sulfuric acid react with potassium hydroxide, it gives salt, which is potassium sulfate, and water. And what actually happened during this process? We know that acidic solution contains hydrogen ion, while the alkali contains hydroxide ion. And when hydrogen ion and hydroxide ion react together, it will neutralize and give water. We are going to look at the applications of neutralization in daily life we use in healthcare, industry, or also agriculture. Next, we are going to look at the acid-base titration. Titration is a quantitative analysis to determine the volume of an acid required to neutralize the fixed volume of alkali. So when doing titration, we will reach at the endpoint. What is the endpoint? It is a point achieved in titration at which the indicator changes color. So we have three indicators here. We have phenolphthalein, methyl orange, and universal indicator solution. We are going to look what happened when this indicator is in the acidic and neutral, also an alkaline medium. For phenolphthalein, in acidic medium, it will turn colorless. And also for neutral, it will also turn colorless, but in alkaline, it will be pink. For methyl orange, if that medium is acidic, it will turn red. And if that medium is neutral, it will remain orange. And if that medium is alkaline, it will turn to yellow. And for universal indicator solution, if the medium is acidic, it will be red or orange or yellow, depends on the pH. And if the medium is neutral, it will turn to green. And if the medium is alkaline, and it will turn to purple. We are going to look at the setup of the acid-base titration. So here is the setup. So this is a burette and also an analyte that contain indicator. During the titration, when analyte change color, it means that the endpoint has reached. When the endpoint has reached, it means that the neutralization has already completed. So here we are going to look at the calculation of acid-base titration. So we have the formula here, which is MAVA over MBVB equals to A over B. So MA is the molarity of acid A, VA is the volume of acid A, and MB is the molarity of alkali B, and VB is the volume of alkali B. This A is represent to the mole of acid A, and B is represent to the mole of alkali B. When doing the calculation for titration, make sure the chemical equation is balanced properly. Next, we are going to look at the salt. We are going to look at the definition, the solubility, the qualitative analysis, and also the application in daily life. Next, we are going to talk about salt. Salt is an ionic compound that can be produced from the neutralization between acid and alkali. And then salt, we have soluble salt and also insoluble salt. Here, for nitrate salt, they are all soluble in water. And for carbonate salt, they are not soluble in water, except for these three. And for chloride salt, they are all soluble in water, except for these three, which is lead chloride, argentum chloride, and mercury chloride. And for sulfate salt, all soluble in water, except for these three. For the preparation of soluble salt, we have two ways, which is for potassium, sodium, and ammonium. We can get by the reaction of acid and alkali, which is a neutralization reaction. But other than potassium, sodium, and ammonium, we can get it by the reaction between acid and metal, and by the reaction acid and metal oxide, also by the reaction between acid and metal carbonate. So here is the example. For reaction between acid and metal, sulfuric acid react with zinc, we can get zinc sulfate. And then between nitric acid and magnesium oxide, we get the magnesium nitrate. And for hydrochloric acid and calcium carbonate, we can get calcium chloride, carbon dioxide, and also water. So next we are going to look at the preparation of insoluble salt, the salt that does not soluble in water. So insoluble salt can be prepared through double decomposition reaction, which two aqueous solution of two different soluble salt are mixed together and then to produce the insoluble salt. And then also we can use a crystallization process, which is a process to crystallize the soluble salt, and we can use recrystallization, which a process to be carried out in order to obtain pure salt. So this is a picture, a diagram that shows a double decomposition reaction. We have two soluble salt here, and then we get the insoluble salt. Next, we are going to look at the qualitative of salt, which is a method that used to determine the cation and anion present in a salt by analyzing its chemical and physical properties. We have four methods, which is number 1 is observation on physical properties in salt, and number 2 is effect of the heat, and number 3 the test for cation and anion, number 4 the confirmatory test for both ion. These four methods is the qualitative of salt. For the first method, observation on physical properties in salt, we can look it based on the color and the solubility of the salt. Here we have the color and the solubility and also the compound that was given. We have iron 2, we have iron 3, we have copper 2, we have iron 3 oxide, copper 2, and we have copper 2 oxide, zinc oxide, lead 2 oxide, and also magnesium oxide and potassium oxide. Next, we are going to look at the second method, which is gas test. Here we have gas, nitric gas, oxygen gas, carbon dioxide gas, ammonia gas, and also hydrogen gas. So we have here the observation of each gas and also the inference of each gas. Here we are going to look at the test for cations. So we have the cation calcium, magnesium, zinc, aluminium, lead, ferrum 2+, ferrum 3+, cuprum 2+, and ammonium. So we have in sodium hydroxide solution and sodium ammonium solution, which is in sodium hydroxide solution, calcium, magnesium, zinc, aluminium, and lead have white precipitate color, and then for ferrum 2+, it has green precipitate color, ferrum 3+ have brown precipitate color, and cuprum 2+ has blue precipitate. For ammonium solution, calcium have no changes in color, but for magnesium, zinc, aluminium, and lead, it has white precipitate color. For ferrum, it has green precipitate color. For ferrum 3+, it has brown precipitate color, and for cuprum 2+, it has blue precipitate color. Next, we are going to look at the test for anion. So the test is being done in 2 cm cubic solution that contains the anion that poured into the test tube. So we have 4 anion here. We have carbonate, chloride, sulfate, and nitrate. So the observation obtained is for carbonate, we have carbon dioxide gas release. For the chloride, we have white precipitation formed. And for sulfate, we have white precipitate form. And for nitrate, we have brown ring form. So here is the ion equation of each anion. So move on to the next slide. Next, we are going to look at the application of salt in daily life. We have MSG, used for food flavoring. We have baking soda, used to make cake or bread. We have argentum bromide in the making of film. And we have ammonium, salt used in fertilizer. And we have calcium sulfate in the making of plaster. And last but least is the table salt, which is sodium chloride. This is the end of the discussion of the chapter 6. So here are the tutorial questions. We have 9 tutorial questions. Please try your best to answer all the questions, and the answer will be given and explained in the second video.
Last but not least, we have quiz, which 10 objective questions will be given based on the video, and here is the link to the quiz, also the code for you to enter the quiz, and please write your full name once you enter the quiz room. And remember, the room is accessible only one time and will be open only for 1 week. Special prizes will be given to the top 3 winners based on the total marks for all the videos. And make sure you do well in all quizzes. Good luck! And here is the QR code for you guys to enter the quiz room.